So in previous chapter, we have completed our comparable and comparator. This time we will start array list, and then we will see linked list and stack and vector. So mostly we have seen these kind of things. So we will be going fast in these three chapters. Okay. So ArrayList is the most commonly used collection in Java, a resizable array that combines the simplicity of arrays with the flexibility of dynamic sizing. So under the hood, it's backed by an array that automatically grows when needed and giving us the best of both worlds. So fast random access with no size limitations. ArrayList versus array. Arrays are fast but rigid. Once created, their size is fixed forever. Okay, so linked list solves this limitation while maintaining the same O1 access speed. Because under the hood, there are also arrays. So under the hood, we have array. So definitely we will get O1 access speed. So for array, fixed at creation, grows, shrinks dynamically. Type, primitives and objects only, and add remove, mutual resizing required, but we have here some built-in methods. Access time, both we have O1. Now creating an array list, always specify the element type using generics. This catches type errors at compile time rather than runtime. So we can import this one from our util package, and then we can create our empty array list. Okay. So we have here different methods to create array list. Okay, so here we can import this one, or maybe we can import everything. Okay, and now we can create here string. So we got one suggestion, and if you open this one, then you can see here we do have element data. Okay, so we have under the hood this array that stores our elements. Okay, so let's say initially we got our capacity 16 by default, or that can be any number. And you can see we can also provide initial size. So initial capacity of 10. You can see constructs an empty list with an initial capacity of 10. So let's say initially we got 10 empty slots, okay, of array basically. So like that we got 10 slots. So when we add 11th element, then we will create new bigger array, okay, and that will be 50% bigger. So we will create 15 slots array, and we will copy all those 10 existing elements into it. So that's how we work with arrays. Okay, so our resizing is basically costly, and if we know that we have to add 10k elements, then we can set our initial size capacity here, let's say 100. All right, now another way is we can also initialize our list or array list with some data. Okay, and that will be new array list, and we can put here something like that. Okay, so our this list too will be initialized with this data. We can also print this. Okay, compile this one. So you can see we got A, B, and C. So that's how we can also initialize our array list. And here we are creating our array list using our list interface. So that's also fine because our array list also implements this one. And we can put our parent reference, okay, in the left side. Okay, you can see here. All right, now let's see. So we can create empty array list. We can create with some initial capacity. We can initialize with some values as well. So capacity versus size. So this one creates capacity for 100 elements, but size is still 0. Okay, if you call method like dot size on this one, then you will still get 0. It's pre-allocating memory to avoid repeated resizing when you know approximately how many elements you will add. This one is another one thing. Now, Next one is adding elements. So ArrayList provides 3 ways to add elements, each for different scenarios. First one, just like that, you can add same kind of element you have declared here. But if you do not declare this type or this generic here, then basically you can add anything. So let's say we remove this one, okay? And then we have to remove this syntax as well. Or maybe we can, so now here we can add anything. We can add integer here, we can add here, let's say string, we can add here Boolean values, so that's still fine. And now we can print this one. So we can compile this, we will get one warning. So that's still fine, we can run this one. So you can see we got this. But this one will be problem, when big problem. So if someone don't know that we have added different kind of elements, then, and if they are doing loop on this one, then basically they will get one problem, something like this. Let's say if someone assume that or array list of type string, then as if you do something like this for each loop, then we will get one error, and that will be required type object. So you have to iterate this one using object. So as everything is object, then this one will work. Now we have one another thing about adding. So we can also add at any particular index. Okay, we will replace, or basically we will add, that means we will shift elements, not replacing this one. Now we can also add all, so add multiple elements at once. You can also do that. When you insert at an index, all elements after that position shift right to make room. This is an ON operation. Okay, so frequent mid-list insertions can be costly. Now next one is accessing elements. Random access is ArrayList strength. So retrieving any element by index takes constant time regardless of list size. So we know that under the hood this one is array, so our accessing time will be O1, all right? But if you try to access like outside the boundaries, then you will get index out of bounds exception, same as arrays. So that's fine. Now next one we have modifying elements. Replace existing elements without changing the list structure. So we have here one method that is set. Set index element. So this one will be your new value. So replace single element returns old value. Okay, so we can also capture its output, and that will be your old value. We can also do replace all. So transform every element using a function, and we will see this syntax in our functional programming. Okay. Now next one we have removing elements. Multiple removal strategies depending on what you know about the element. So let's say we have this array list. Okay, we have this data. So by index, we can also removes and returns the element. So string removed, list dot remove this one. If you just put like simple integer value, then we will be removing by index. So we will remove here b. So from 0 based indexing. Now our resulting array list will be like that. We can also remove by value. So removes first occurrence only. So conditional removes all matching, and that will be one predicate. So we will see this this lambda syntax in our next topic, functional programming. This one is very easy. Okay, so if you will see its method signature, this will take one predicate. So predicate just one functional interface that is that has one abstract method and with return type like Boolean. Okay, so we'll see just one. This one is one of core functional interfaces from our functional programming. Now next one is bulk. Removes all elements from another collection. So list.remove all, like that. So this time, so at this point of time, if we follow this sequence, at this point of time, we have our array list something like that. and we started from this data, and at this position we have this one. Now if you do remove all list.off, then we will remove this one. Now at this point we have this. Okay, now we have this one. So dot clear method we have on every collection. Okay, so this one will just clean our collection. Now we will get empty array list. Okay, so we can see this one, integer ambiguity. So with array list of type integer, if we do something like remove one, so this one will remove index one value. Okay, not like integer one if your array list contains one. So if you want to remove like that integer one, then you have to use integer dot value of syntax. Okay. Now next one is searching elements. So finding elements or checking their existence. Let's say we have this array list ABCD, ABCBD. So existence check, boolean found, list dot contains. Okay, so this method is common in all collections. So you can check any value. So list dot contains B. Yes, our list has this one. So we will get true. Now next one is position finding. So list dot index of this one. So we will get first occurrence index value, that is 1 in this case. So we also have one method last index of. So in this case we will get 3 from here. And then we have int missing. So list dot index of. If our list doesn't have anything, any value that we are trying to match, then we will get -1. We can also check multiple elements. So contains all, we have this one. So that's how we can work with array list, searching elements, removing elements, modifying, accessing, adding. Okay. So some common ones we have here. Now we have size and capacity. So basically we have this size method that we can call basically on any collection. And this is the benefit of unified architecture of collections. Okay, you will find similar methods in basically all collections. Now here we can see use ensure capacity. When you are about to add thousands of elements, it avoids the overhead of repeatedly growing the internal array. So here you can provide your initial capacity limit if you know the approximate range. Okay. Now next one we have iterating array list. So choose your iteration style based on what you need to do. Let's say we have this array list. So for each, cleanest for simple iteration, just simple like that. Okay. And if you see our array list, this implements list. This extends abstract list. And here you can see extends abstract collection. And if you open this one, implements collection. So we have, so here you can see our collection extends iterable. So any class or an interface that extends this one, like iterable interface. And we will see this one in our this same topic. So if any class implements or extends this interface, then we can use this for each syntax. Now we have traditional for. When you need the index, then you can do that. Simple loop. Okay, lambda, we can skip this one for now. Then we have iterator. We can also skip this one. So concurrent modification exception. If you try to remove elements from your list, so if you are doing this and if you are trying to remove elements, then basically you will get this. Okay, concurrent modification exception. So if you want to remove elements while iterating, then you can use iterator. Okay. So never use this one, list.remove inside a for each loop. Basically here we can use iterator.remove or remove if instead. So we'll see these ones later. So maybe we can see this one, quick practice. We can come here. We can paste this one here basically. So this one will be fine. And if you try to remove something, let's say names dot remove name. Then here we will get concurrent modification exception, compile, and this one will be our runtime error. You can see, okay. So if we have to remove while iterating, then we can use iterator, okay. And we have some internal implementations like mode count, expected mode count. So those two variables should be equal. And we'll see this one in our iterable chapter, okay. Now next one we have sorting. ArrayList elements can be sorted in various ways using either the list's own method or the collections utility class, and we will see this one after iterable chapter. Okay, so that's fine. We can see some basic ones here. So let's say we have this array list. Now natural order. Natural order means for strings that will be alphabetical and for numbers that will be ascending. Okay. So if you sort this one, then we will get Alice based on alphabetical order sorting. So we can also do reverse order, comparator.reverse order. We have seen this one in our previous chapter. Okay. Now custom comparator, we can also do that. Comparator.comparing. We have covered these things in our previous chapter. Okay. Now we also have some utility operations. We will see those later. Collections.reverse, collections.shuffle. You can also understand by their names. So for reverse, just it will reverse whatever you have now, not sorting related kind of things, just reversing your elements. Shuffle means just shuffling your elements randomly. Now next one we have converting. We can also convert our array list to array. So we have one method that is list.toArray. Okay. And here we have to pass, let's say we can pass here size limit 0. Now you might wonder that what this mean. So if we pass here just initial limit of 0, that doesn't matter. Okay. Internally, our this method or our array list implementation will check how many elements we have, and according to that, it will automatically create its size. Okay. So that's fine. Extract portion returns a view, not a copy. So let's say if you want to see some view, then you can see list.sublist 1 to 4. We will get, so this 4 will be exclusive. So we will get B, C, and D. But if you modify or if you do something here, then our this view will change. Okay. So maybe we can do some practice here. Okay, so that's fine. We can remove this one. And if we do something like with our this view, then our original will also get modified. We can clear this, compile this, and we can run this one. So now you can see we got A and E. Okay. And also if we don't do this one, but if we change, we can print here one thing. Okay, so then we can also modify here list dot add. Let's say we can add at index 1, we can add x. Okay, now if we print this one as well as if we print sub, then you will see the difference. Compile this, run this one. Okay, so we got one thing, that is concurrent modification exception, and that is from our line 15. So after modifying, we cannot traverse on this one. Okay, so this one is one thing. You can see here we modified our original. Okay, and here we had our this view. So same thing we are doing here. Basically we have started one iteration. Okay, and while iterating, basically we cannot modify. Here basically we increased our mode count for this iterator, okay, that we have set here, and that one will mismatch with expected mode count. So we will see those things later. For now you can skip. So here the point is we will get one exception, not any normal result. Now next one is performance summary. So get index, then set, we have here O1. So same arrays we have under the hood. Add element. This one is amortized. So occasional resize, and that will be ON. Add, this one will be ON because we have to do shifting of our elements. Contains linear search, that will be ON. Now we have to use ArrayList. ArrayList excels when you access elements by index, and mostly add remove at the end. If you need frequent insertions in the middle, we can definitely consider linked list. We will see in next chapter what is that. If you need fast lookups by value, you can consider hash set. We'll also see that one later. We have quick summary and we can move forward with our next chapter, which is linked list.